Okay, this is quite straightforward lah, but there's something that we have to be that we need to take note of. So they ask for the sum of alpha squared. Okay, so for that one, okay, we know that we can use sum of alpha, which is negative b over a. Okay, and we also have sum of alpha beta, which is c over a, which is 3 in this case. So to find the sum of the alpha squared, so in this case there will be sum of the alpha whole thing squared minus 2 sum of alpha beta. So that would be negative 2 squared minus 2 times 3, which we get a negative 2. So we cannot have the sum of squared of the real numbers to be a negative. So in this case, we'll have complex roots. But when we actually try to list down the nature of the roots, okay, we have to be careful also. We have to really say really clearly, okay, that we have got one real root. Okay, and then because the complex root must occur in conjugate pairs, so it would be good if we say and we have two complex conjugate roots. Okay, so with that it is more clear and precise lah. Okay, so basically this is the question for you to warm up only lah. Okay, let's look at the next question. Okay, so quite a bit of work of this question, so you can take a bit of time to complete that first. Okay, I think we'll look at the questions in 1 minute time. So try to finish it. Okay, let's start. Right. So first part, okay, state in terms of A, B, and C, okay, all these value. Basically, this is not difficult to do. Okay, so just state them. So and they are actually all nice values, which we have the A, B, and the C lah for the three things. Okay, so just let it write it down first. Okay, so it's very simple, and next one, okay, find in terms of A, B, and C of sum of squares of the roots, and then we have the alpha square, beta square, and so on. This one. So okay, for this part 2, right? First one is easy. So first one is actually our summation of the alpha square. So this is, we have done this many times already lah. So we should be able to do this. Okay, so sum of alpha squared here is a squared minus 2b. Okay, this is very simple. Okay, so what about the next one? Okay, so if we look at the nature of the next one, right, it is also something like sum of squares. So we can also look at this as like the sum of the squares of the product of any two roots. Okay, so this is the way that we can actually look at it. So what is the value for this one? Okay, is okay. The relationship that we can use for this one is that, okay, if we just consider this one, the usual sum of squares, okay, the formula for the sum of squares, let's say we consider this one. So what do we mean by here is when we actually square the roots, okay, it will be this expression. So now what we want to find is we want to find the sum of the alpha beta in the bracket square. So how can we actually use this kind of the relationship to find, okay, the value of this is that. So just replace all the alphas, okay, in the relationship with alpha beta. So let's say for this one, instead of alpha, we have got alpha beta. We replace it with alpha beta. Sorry, this is alpha. So for the sum of the alpha square, like what we did just now, we replace the alpha with the alpha beta. Okay, so what happened to this one? This one is we actually take any two roots, okay, and then we actually multiply them together and then we add them up. So in this case, just now what we did was we replaced the alpha with the alpha beta already, okay, so replace the alpha with the alpha beta. So what about the beta? The beta actually just means another root, which is other than the alpha beta. So we just take something like beta gamma, okay. So if we have beta gamma, so when we actually replace the beta gamma, okay, to the beta, we actually have alpha beta square gamma. Okay, so for the first two terms that we have here is very easy to understand, okay. But what happened to this thing? Okay, the sum of alpha beta square gamma, okay, is that, so let's just write that down first. So again, what is meant by the sum of alpha beta squared gamma is that is basically alpha beta squared gamma plus so we just squared the beta already, so now we just square the other roots, So this is basically what it means. So how do we get this? Is we factorize out the alpha beta gamma, then we will actually have alpha plus beta plus gamma in this case. Alright, so this is just summation of alpha beta whole thing squared minus 2 times summation of alpha beta gamma times with a summation of alpha. Okay, so if we actually try to expand the right hand side here, okay, we should be able to get the same thing lah. Okay, this relationship. So just substitute the values in. So we have got this is b squared minus 2 times 2ac. Okay, so this is a relationship that we get for this b squared minus 2ac log. Okay, as for part 3, right? Okay, so for part 3, I'm not sure, okay, whether we have an easier way to work with it or not, because looking at the marks is 4 marks, so it's quite, actually it's quite a lot of work. I'm not sure whether we have some other easier way to look at it, but I think the most straightforward way that I did was, I just expand everything. Okay, so after we expand that whole thing, right, okay, let's just write down what is the expression first. So after I expand everything, right, I will actually get this. Okay, so you check whether you get the same expression or not. Okay, and other terms like okay, so I think if you actually expand and arrange everything nicely, these are the terms that you actually get. So basically, the purpose that they ask us to do this second part is that we actually use the result from the second part and the first part, and we just substitute everything inside here, lor. Okay, so of course the simplifying work, as long as we get the correct expression until now, so simplifying work should actually gives us the result lah. So basically we just substitute the results that we have earlier on, and from there we should get the result lah. Okay, so this is our result. Okay, so this is what we're supposed to prove. Okay, so that is part 3. Okay, so for the question in part 4, they says, okay, deduce that one root of the equation which you have this is twice the product of the other two roots, okay, if and only if we have c of 2a plus 1 squared is equals to 2 times b plus 2c squared. So for this one, right, so how do we actually get that c something squared equals to 2b something squared? So that is basically what we have in the third part. Okay, so so how do we show this is that because they say if one of the root is twice the product of the other two roots. So what do we have for the roots is that, okay, let's say we fix the alpha is one of our roots. So we know that this root is twice the product of the other two roots. So let's say this is what we have. So what happens is we have a minus 2 beta gamma is equals to 0. Okay, so if we have this thing is equals to 0, means in our relationship which is in the part 3, the whole left hand side will be equals to 0 already, lor. So that will give us the expression where we have proven just now is equals to 0. So this is why we can actually prove that the c times 2a plus 1 squared should be equals to 2b plus 2c squared. Okay, so this is the thing that we should be able to get lor. Okay, so this question is a bit longer, okay, but it is not too difficult to prove lah because all the results are given already. Okay, so okay, with that let's look at the next question. So there are two parts of the question A and B which are different. They are not related. So you can try both first. Okay, let's look at the question. Okay, so for part A, this QB equation, okay, has roots PQR, and then we are supposed to find another equation which has roots QR, RP, and PQ. So show how the substitution y equals to 4OX can be used to determine this second equation. So okay, from there is usually by using our method that we will let y to be a QR. Okay, so this is usually the method that we do. So because we want to only have the root as a subject, one of the root as a subject. So how do we eliminate this? Is that okay? We can multiply p to both sides. And we know that this PQR is the product of all the roots law, which is negative d over a in this case. So for this negative d over a is a 4. So we have y is equals to 4 over p, which we can write it as y is equals to 4 over x, because p is just a root of the equation, which is in terms of x. Okay, so next, how do we actually find the equation in terms of the y? Is that okay? We just rearrange law. So x is equals to 4 over y. Okay, and then after that, what we need to do is we just have to substitute this x equals to 4 over y into the equation that we have for the x. Okay, and from there is basically expanding everything carefully, and at the end we should be able to get an answer lah. So let's check whether you get this answer or not. Okay, so this would be the answer for the question A. Okay, so let's look at question B. Sorry, let's look at question B. Okay, for question B, right, it's about, okay, we look at the question again. So question B is about, we have a QB equation again. Now the roots are alpha, beta, and gamma. So it is given that alpha is real and positive, and another two would be complex. So describe the relationship between beta and gamma. So they are conjugate law. So beta and gamma are complex conjugate. Okay, so must say they are conjugate. Okay, next part, part 2. So for this, okay, is explain why we have the modulus of b is equals to 2 over root a. So this question is a bit similar to one of the question in the past year. So how do we deal with this one? Is that okay, because we are looking at the modulus of b. So because b is a complex number, so the modulus of the b means we are looking at the magnitude or the modulus of that complex number. So what can we do is just give b the beta and the gamma a name law. Let's say we call beta as a plus bi. So we know that the gamma in this case is a minus bi. Okay, so this is what we can actually first do. And after that, let's just look at, okay, because they asked about the modulus of the b so in this case the modulus of the b is just a squared plus b squared, and we take the root of it law. So this is the same as actually the modulus of the lambda in this case, and this is also the same as if we actually multiply the beta and gamma together. So when we multiply beta and gamma together, we get a squared plus b squared, but for this one we need to take a root, okay, because it is root of a squared plus b squared. So all these things, they are actually equal. Okay, so how do we start is we know that, okay, in that case the alpha beta gamma is equals to 4. So in this case it's negative d over a again from the question. So because we want to get like 2 right in the showing, so we just take square root for each side there law. So left hand side we take the root as well, right hand side we also take the root. So okay, what we have is we will have beta gamma, okay, the square root of it is equals to 2 over root of alpha. So the right hand side we have already proven it. So the left hand side is just take the modulus of the beta law. So in that case the modulus of the beta is 2 over square root of the alpha. Okay, so this is how we do the second part. Okay, third part. So verify that alpha equals to 2.70, correct to three significant figures, and deduce that real part of beta is 0.65. Okay, correct to two significant figures. Okay, so how do we do this? So the first part, verifying. So for this verifying, right, is because they already told us 2.70 is the alpha. So alpha is the real root. So how do we prove it's a real root? So we basically just have to sub this 2.70 into the equation and show that it is equal to 0. So nothing much lor. This is about verifying lor. Okay. So how do we move on to the next one? Is that okay? Now we considered just now the alpha, beta, and gamma ma. So now we use some other info. Let's say we use alpha plus beta plus gamma. So this is equal to 4. Okay, negative BOA. So we already know the value of the alpha they already gives us. Okay, is 2.70. So it gives us the beta plus gamma is 1.30. So what are our beta and gamma? They are just A plus BI and A minus BI lor. Okay, so in this case the BI will cancel off so we only have 2A. So our A is 0.65. So again, what is our A? The A is the real part for either beta or gamma So they are asking for the beta so we just write lor. So this is a real part for the beta. Okay, so this is how we prove this question. Okay, so that would be for part 3. Okay, so we look at another question from here. This one I'll upload it as an exercise. Okay, I'll include the answer as well, so you can try this later. We will actually look at this one. So this one, I think you can finish it within like 3 minutes lah. So let's try to finish it within 3 minutes. You can try that first. Okay, so let's look at the question. So first part, okay, express x cubed plus y cubed in terms of x plus y and xy. So I guess this one is you can do it, okay, by start expanding the x plus y cube. Okay, so you can start by doing this, then you will get something. Okay, you just try to expand this. So just try to rearrange it until you get x cubed plus y cubed. So the result is x cubed plus y cubed is equals to x plus y whole thing cube minus 3xy times x plus y. Okay, so this is the result that we should get. Okay, part 2. The equation, okay, given here has roots alpha and beta. So determine the values of the alpha cube and beta cube. So actually first part has already helped us, okay, in doing this. So basically what we need to find out is just, we need to find out the alpha plus beta, which is negative b over a, and alpha beta is a c over a. Okay, we have got both values here. So what we need to do is just substitute the alpha and beta as the x and y. So this one is alpha plus beta power 3. So alpha plus beta is a 3. Minus 3 xy. Xy is just our alpha beta law, 8 over 9. And this is again alpha plus beta. So it's a 3. So we will actually get a 19 from that. Okay. So part B. Okay. Hence, express 19 as the sum of cubes of two positive rational numbers. So because what happens is that we have been using the alpha plus beta and alpha beta, we are able to get this, okay, 19. So what are actually our alpha and beta? They are actually our roots law. So how do we get the alpha and beta? Is of course solving this quadratic equation. So this quadratic equation is t squared minus 3t plus 8 over 9 is equal to 0. Okay, so by solving this, we get t minus 1 over 3 and t minus 8 over 3. So we have got t is equal to 1 over 3 and t is equal to 8 over 3. So these two values would be our alpha and beta. So we can let alpha equals to 1 over 3 and beta is equals to 8 over 3. So therefore, okay, from the result that we have from the part A, the second one, part A, so for this one, our 19 can be written as alpha cube plus beta cube. Okay, so this is how we do this last part. Okay, so thank you. I'll see you in the next video. Take care.